So a polygon is the definition from the book, a closed figure in a plane okay. It has segments called the sides. So the sides are line segments. They intersect only at their endpoints. Okay, so some examples of things that are polygons. I'm going to draw them a little up here. So has to be line segments. Okay. Can't have things that are not polygons over here. No curvy stuff. Even if there's some things that are straight. It can't be open. Okay. It can, as long as it's closed, it doesn't really matter what shape. Okay. No crisscrossy stuff. No crisscrossy stuff, not a polygon. Okay, so the ones on the right are not polygons. Can't have curvy stuff, can't be open. The ones over here are polygons. Okay, that's fine. You also can't have anything sticking out. You know, something like that would not be a polygon because it doesn't intersect at the end point there. Okay, those points of intersection are called, each one of those is called a vertex, or the plural of that is vertices. Okay, so the vertex is the points where the sides intersect. Those are the corners. So a polygon can either be concave or convex. So usually I like to kind of think of concave as, does it cave in somewhere? So concave might look like this. Okay, that would be concave. And I kind of think of it as it caves in there. Okay, convex, it does not cave in. Okay, and looks more like that. The official way that you can test for that is if you extend any one line and it cuts through the polygon, it's concave. You know, if I highlight any of these and extend them, it doesn't cut through the polygon. It doesn't cut through the polygon. And it could do that with any one of them, and it doesn't. It's concave and convex. So polygons have names, and most of these are things you're familiar with. And we have triangles. Now, usually when I ask this, when we are just, you know, hey, what's four-sided? I get square, rectangle. Yeah, yes, those are four-sided figures. The general name for all four-sided figures is just quadrilateral. Okay, and then that suffix lateral means side, so four sides. Okay, we've got 5 sides is a pentagon, and these are all in your textbook. Hexagon for 6 sides. One that is harder for us to remember sometimes is heptagon, or when we need to make it septagon or something, the 7 starts with an S, but it's heptagon. 8 would be octagon, we're pretty familiar with that. 9 is a nonagon. Sometimes you will see the word enneagon. Okay. 10 would be a decagon. 11 wasn't a big deal. 12, dodecagon. Okay. And actually, they all have names. We could keep going. 15 is pentadecagon. And we could keep going, but the names actually get pretty ridiculous. I think you could look it up, you could Google it, it's kind of fun. After that, maybe we just say it's an n-gon. If I have a polygon with with 37 sides. I might just call it a 37gon because its real name is really long and crazy. Okay, so polygons can be equiangular. Okay, they can be equiangular, so equal angles. They can be equilateral, which means equal sides. So this, if a polygon is equiangular, all of its angles are congruent. Every one of its angles is the same size. If it's equilateral, all of its sides are congruent. All of its sides are the same. And we call a polygon regular if it is both equiangular and equilateral. Okay, so a stop sign is a regular octagon. So if we just look at these, it's asking us to do a few things. Name it, tell me whether it's convex or concave, and tell me whether it's regular or irregular. So this one has 4 sides, so it's a quadrilateral. It does not cave in anywhere, so it's not concave, it's convex. And the sides are all different lengths, the angles are all different. It is not regular, it is irregular. Okay, part B, this green one here, it's got 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. It's got 9 sides. So 9 sides is a nonagon. It does cave in, okay? It does cave in. If I highlight one side and keep going, it cuts through. So that would be concave. And then it's all different sizes and angles. It's irregular. Any polygon that's concave is automatically irregular. Its angles cannot all be the same if it's concave. So the star here has 10 sides. So it's a decagon. And it's concave. It caves in at all these spots. It caves in at all those spots. So concave. And this is the one that I'll often get, oh, it's regular. No, all the sides are the same length, but all the angles are not. Okay, because you've got these more than 180 degree angles. So those 5 red ones are the same, and the other 5 are the same, but they're not all 5 the same, or all 10 the same. So that would be irregular. So then this one over here by the markings, it's got 6 sides, so it's a hexagon, and it is convex. There's nowhere where it caves in. But notice all of the angles are marked congruent. Okay, all of the angles are marked congruent. All of the sides are marked congruent. Since it's both equiangular and equilateral, it is a regular hexagon. Okay. So we have some formulas for, oops, I need to come back, I'm sorry, come back up here. So we have some formulas for some of the interior angles of a polygon. Okay, so the little subscript I means some of the interior. So if we have a regular, it doesn't have to be regular, any old polygon that's convex. If I put in diagonal, so a diagonal is a line that goes from one vertex to another, and it's not a side. Okay, so if I do all the diagonals that I can from this one vertex, I've created 1, 2, 3, 4 triangles. Okay, this has 6 sides. I can separate it into 4 triangles. I could do that with a pentagon. Okay, if I do all of the diagonals from one vertex, I run out. This one had 5 sides. It has 3, 1, 2, 3 triangles. Okay, and I could do that with a whole bunch of them. This is always going to be 2 less. Well, every triangle has 180 degrees in it. So the formula for the sum of the angles is n minus 2. So the number of sides minus 2 times 180. Okay, because each triangle has 180 degrees, so we need 4. So if we did for a hexagon 4 times 180, we would have 720 degrees. So down here, if I do 3 triangles times 180 degrees, it would be 540 degrees. The triangles have 180, rectangles have 360, you know, and then after that we need to use this formula for how many degrees it has. So we get sum of the interiors n minus 2 times 180, n is the number of sides. So we use that formula. Okay, so this has 1, 2, 3, 4, 5 sides. So since it has 5 sides, the sum of the interior is going to be 5 minus 2, so 3 times 180, which is 540. Okay, so we can also try working that backwards. What kind of polygon do I have if the sum of its angles is 1080? Well, so in that formula, the 1080 actually goes in for that is the sum. That's the f sub I. Minus 2 times 180. So I need to solve for n. I can do that, divide by 180. And so, so divide by 180. That is 6 equals minus 2, add 2 to both sides, and equals 8. So, it asks me what is the name of the polygon. Well, it's got 8 sides, which means it's an octagon. Okay. Now, if the measure of each interior angle is 140, how many sides does it have? Well, now what we need to do is, the way I like to approach this is, let's take a look at, we have what's called interior angles and exterior angles. So I'm just going to draw a hexagon this time. Okay, so these are the interior angles. Okay, these are the interior angles. I'm just going to mark them each differently. This is not necessarily a regular hexagon. An exterior angle is formed when you extend one of the sides. Then this is the exterior. Okay, so what should we know about an interior and an exterior? They're a linear pair, so they should add up to 180. So if my hexagon happens to be regular, so we're going to try to make it as good as I can here, which means all of these are the same size. Not very good. So we'll say all of these are the same size. Okay, and then that means all of the exteriors are the same size. And whatever this one is the same as this one, is the same as this one, and so on. So there's a theorem that says for any polygon, okay, for any convex polygon, the sum of the exterior angles is always 360 degrees. It doesn't matter how many sides it has. It's always 360 degrees. It's kind of my favorite little theorem from geometry. So, when I'm looking at this one, the measure of each interior is 140. So I'm just going to like draw one corner of the polygon. There's more polygon out here, but I don't know what it is, so I don't know how many sides to draw. If this is 140, if I extend that and make an exterior out here, how big does this exterior have to be? Well, that's a linear pair, which would have to be 40. Okay, so for each of those, if the sum of the exteriors is 360, and each one of them is 40, the number of them should be 360 divided by 40, which is 9. So this thing has 9 sides. If we needed its names,